Hi everyone, this is Tamu. Welcome to my channel, The Cloud Security Guy. In case you are new here, we talk on a weekly basis about things like cloud security, artificial intelligence risks, and general cybersecurity career advice. So today, we're going to talk about another very important topic. It's like a mini course. It's like continuing on from the previous course which I did on cloud security basics. Cloud security 101. A lot of people actually like that, so I thought I'll continue on a very important topic, which is API security best practices, or I call it API security 101. Why this topic? So, just a quick brief background, guys. Just how many applications do you use every day? If I ask you to just think about how many applications do you work with at home, at work, for booking movie tickets, to check social media, so many apps you can't even count them, right? Apps are pretty much how we live our digital lives, right? And APIs are the backbone of these software, these applications, and today's apps, they are in the cloud, they are on-prem, they have thousands of integrations with other applications in the cloud on-prem. Data is flowing from these applications, right? And this is where APIs come in. So the API is basically how software talks to each other, right? And APIs, I think 96% of businesses, I read a study that they are using APIs. But APIs, they also pose a risk to companies if you don't know how to mitigate them. By 2022, Gartner was saying that API attacks will become the most common type of attack. Okay, it could result in a 600 billion yearly loss. So that's why the reason I made this a video, which is I call it API security best practices or API security 101. I want to explain the concepts of API from scratch, what it is, and the different threats that are there. If you've never heard of an API before, or you know it but you don't know what the concepts are, this is a video for you. I'm going to summarize all the key concepts like I did in Cloud Security 101. So, but by the end, you should have a very firm understanding of API, the common attacks, and what to do to protect yourself. And if you are interested, then from this 101 course, you can build upon more advanced topics from API going forward. But this is just to set the foundation so you understand. So, before we start, guys, please do like and subscribe to this channel. Like, share, comment as much as you can. That will really help the video to grow, for this channel to grow, and it will reach the maximum amount of people, and we can share and create more and more cloud security and API advice, right? So let's start from the very basic, right? What is an API, guys? So you must have heard API, right? I mean, you can't really work in IT without hearing about API. Your vendors will be saying we have an API, your IT team is saying we can expose APIs. So let's go right to the very start. So what's the industry standard definition? So it's the acronym for application programming interface. Basically, simple things, how application or software talk to each other. It is basically it forms the backbone for today's application ecosystem. How applications today work, whether it's your YouTube, social media, Facebook, your banking systems, internet banking, everything is running on API. It doesn't matter if it's on the cloud or on-prem, there will be an API there. Okay. So simple words, what does an API do? It's a mechanism. It allows software systems to communicate or to talk to each other. Simply, in its most simplest form, it allows two applications to talk to each other. So you can say, now this app one wants to talk to app two and vice versa. They can talk through an API. Now you might say, why don't they just talk to each other directly, right? The IT can write some function here and function there, and they can talk to each other. Well, they can. I mean, what do you call? They can send a request there and they can talk directly. But why don't they do it directly? You might ask. Okay, why is an API needed in the between? Well, to understand that, let's look at a very simple example. So I want you to imagine you're sitting at a restaurant, right? You have a menu of choices to order from. So, and you have you want the kitchen to prepare this and all that. How do you communicate to the kitchen? Do you barge in and start talking to the chef? No, you go through a waiter, right? You go to the waiter, this is what I want. The waiter goes to the chef and he communicates back the food to you, right? If everybody in the restaurant started going into the kitchen, it'll become like crazy, right? The chef won't be able to focus and all that. So this is where the waiter or the API comes in. The waiter, you can think of it, the messenger or the API. It takes your request and order. It tells the kitchen or the system or the application what to do. Then the waiter gets the response back and it gets it back to you. This is what I want you to think about APIs. Why APIs are needed. Why it is so important. Now let's look at it from a technical perspective, right? How would you talk about, supposing we have a banking app, okay? So a banking app, and supposing customers want to know the balance, right? They want to know the balance of their accounts. They might look at it from a smartphone, an ATM, or internet banking, or on and on and on, right? But so you can imagine if all of them were plugging directly into the banking application, it would be a nightmare for the IT team, right? You would have to accommodate each of them differently. Security issue also, you don't want all of these things directly getting access to your backend systems without something in between, right? This is where an API comes in. So it acts like an interface. It exposes like an API. So your banking applications is exposing an API call, say get balances. All these applications can just talk to the API and get the response back. The banking app, in return, only deals with the API requests and responses back. So you can keep, you see now, understand, I hope you understand why APIs are so awesome, right? That's why they're so cool. So you can keep on adding more and more applications. You might add an IVR here, phone banking system, more and more systems you can add here, right? And it'll easily scale because they all have to just communicate with this API. And now you can understand why APIs are so cool, right? This enables you to scale it and all the benefits come. So what are the key benefits of APIs? So let's take a look. First of all is abstraction or insulation. So the app is basically abstracted away from the other applications. You don't need to know what the technology is, what the security is. You just need to follow the API. There are many, many standards, right? REST API, SOAP. We don't need to get into those details, but there are some standards which the industry follows. You can just communicate in those standards, so it doesn't matter what the backend application is, right? And of course, there are some security benefits. You can imagine the application is hidden, right? You don't have access to the backend application, what the software is, and everything, right? And of course, the performance improves. And we'll see more details about that. As you can see, we can implement things like API gateway to abstract away, and like you can keep on adding more and more. It'll effectively manage it. And of course, scalability. You can keep on adding more and more apps, and the backend, what do you call the application? It will not change. No coding will have to be changed. You can move, say, an app will be on-prem, and you can move it to the cloud. And the users or the other applications, they will not know the difference because they are still talking to the API, right? They don't care what happened to the backend application, whether it was moved to a container, moved to our cloud, on-prem. All of it is just interacting with the API. So I hope you understood the benefits of API, why they are so useful, and like why now today we live in an API world, right? Whether it's on-prem or cloud. And that brings us to my next topic, which is API security, right? Security best practices. So as more and more enterprises are shifting towards this digital means, right? And the risk of API attacks are increasing. That's why API security is so important, right? Just like application security became very, very important like 10, 15 years back because attacks were happening again and again. API security was also a blind spot in many, many companies I've seen. Most companies, they do not have API security programs and they pay the price for this. When something happens, a data breach happens, you do not need to be a programmer to understand API security, but you should understand the concepts behind it. And then you can go as deep as you want. That's the whole point of making this course, the API security best practices, API security 101, because I want to make API security easy to understand. And then it's up to you how deep you want to go into this, okay? So let's move ahead, guys. Let's move on to the next module now. So I know now I hope you understood what APIs are and why they are so useful. So now moving on to API security. Why is it so important? Like I said, by 2022, Gartner, they are predicting that API abuses will become the most common type of attack and resulting in 600 billion yearly cost, right? And API security, this is how, like, what does it mean exactly when I say API security? So API security, basically it forms, we're talking about the whole framework of like policies, procedures, technical controls to secure your APIs because you want to mitigate the attacks which are happening on it. There are a lot of API attacks which happen. We'll go into the detail. And if your API is compromised or exposed or hacked, that can lead to a major, major data breach. They can expose PII, PCI data. It can lead to a massive data breach. So this is why you need to understand it, right? And like it really depends on what type of app is there, but you need to really have some sort of understanding of how APIs need to be secured. So why is API security important? Okay, what can happen? Like I told you, well, your PII data can get exposed. Okay, personally identified information. You can expose PCI data, cardholder data. Your IP can get exposed. The backend application can get exposed, and it can reveal everything about that application. So attacker can steal that. Okay, data breaches. If an attacker say it's like a banking API, right, and he manages to compromise it and get the balances of everybody, so that's like a major, major data breach. He can also cause a denial of service. He can cause his systems to go down through an API. And like I said, it can result in a complete and total data breach. So that's why this is not, I'm trying to exaggerate. but this is actually what can happen if your APIs are not secured, right? So let's take a look at a few examples. What am I talking about? Let's take a look here, right? APIs are the gateway to your systems, right? So an attacker can send a malicious API call. So you have an API here, get balances, right? So this is why did you make it? Because your banking app, it can give the balance back. So if I send a call through my mobile app, it's going to send me my balance back. If I'm an attacker, I can compromise this API. I can say, okay, instead of my balance, show me the balances of other customers. Or maybe I can say, show me other data, show me the user IDs and passwords. Or maybe I can just bring the API down, effectively doing a denial of service attack on your banking application. So your banking application will completely get compromised. So, and these attacks have happened before. There was one attack on I think on an American, like a bank credit scoring application. So he was able to increase his credit score because he was able to compromise the API. Mostly the APIs are publicly exposed, right? And usually people can access it. That's why they become so dangerous. And people do not give it the importance they give, say, your web applications or other things. That's why APIs are so important. So I hope you understood, guys, why I'm focusing so much on API and why I believe there is not enough security awareness about API security risks. That's why I'm taking the time to explain it properly. So let's talk about API risks. Now I talked about why APIs can be so risky. Let's go step by step. So the best way to look at it is to follow some like benchmark or a standard. And I chose the OWASP API Security Top 10. If you are in security, you will be familiar with OWASP, right? It's the Open Web Application Security Project. They are a non-profit community. They are behind the very famous OWASP Application Security Top 10, which I think every company in the world, every pen tester, hacker knows about it, right? SQL injection and all those other things. So they took a look at it and they saw that APIs are becoming very, very dangerous and a lot of attacks are happening at the API level. So they decided to make a separate list just focusing on API security and they released it. So I'm going to use this one because it's a very excellent resource. I'm not saying this is the only one. There are other ones also, but you can take a look at that and just decide what you can do about it, okay? So let's take a look. What are the API attacks? I'm not gonna go like just read off the bullet points here because that becomes boring. Well, the first one is broken object level authorization. What does that mean? Simply put, the attacker, they can send like some other data along with the API. So they can send an ID which doesn't belong to them. And the application, it doesn't check it. It doesn't check what the attacker is sending, and then it sends the incorrect data back. So it can result in data leakage. And this is the most common and the most dangerous attack on APIs. This is the one which has happened the most on the most number of companies, right? So let's say there's a guy using a smartphone here. He says get balance, and the API sends the user ID is going, right? So it goes to the banking app, and you get the data back. But what if there's an attacker? He figures this out. So instead of this own, like he sends this guy's user ID. So the API is going to actually send it back. Why? Because it is not authenticating. It's not looking at other stuff. It's not looking whether it's coming from this smartphone. It's just checking whether the user ID is coming. If I change the user number, it's going to just take that data and send it back without authenticating. So it's a very, very simple attack, but that's why it has been so successful and the most dangerous attack on APIs so far. So what do you do? Well, the main thing is to implement a proper authorization system. You need to check in if the logged in user actually has like the authorization to do this sort of actions. Every action you do, you need to check it whether this user is validated or not. A lot of people make the mistake, they only validate at the start and then they forget about it. And you don't want to have these sort of user IDs. Just going back, just go back. Yeah, not like 111, 222, 123, 456, like a sequence, right? You want to have some sort of a random numbers because that way the attacker will not be able to predict. If my user ID is 123 and I know another guy who his ID is 124, then I know like maybe there's a sequential number going on and I can try and compromise that. So that's why it's so important to have it like a random thing and to have proper authentication. Okay, what's the other type of attack that can be? Broken user authentication. This is a very interesting attack because what it does is it targets those APIs which authenticate users. A lot of users, developers, they forget that the authentication APIs are one of the most sensitive areas, right? And it becomes an easy target because it has to be exposed publicly, right? If you're a banking app or something, you need to be able to some way to like reset your user's password or something like that. They can try to trick this authentication API and gain access to other people's accounts. And then they can do some other things like money transfers and like withdraw money, transfer money. All these things can be happen. So let's take a look at this. So supposing I send uh, I'm an attacker, and I know there's a guy called Tim. That's all I know. His user ID is Tim, right? I can try to communicate with this API. I know it's a reset password, right? I'll send it Tim, and the application, it's not dumb. It's going to send a token back. But what I do is I know for the fact that that token API is not implemented properly, right? I start brute forcing the token. I know it's like a 4-digit character, right? I can start sending all sorts of attacks or numbers, random numbers, brute forcing it. And what is happening? The API, it doesn't lock the user out. It doesn't check that how many attacks are coming per second. If one user is sending like 10,000, what do you call, a token authentication attempts in 1 minute, that should be a red flag, right? But you haven't implemented this, or it's not blocking. If it sees like one user is sending thousands and thousands of token resets, the token guessing attempts, instead of blocking it, just allowing it, then you have a broken user authentication. So easily this attacker will be able to compromise Tim's ID, and then he can gain access to the application, right? So what do you need to do? You need to check all possible ways APIs authenticate. And APIs which have like focus on password resets or one-time tokens, one-time links, that have to be protected. You need to put in other controls, right? Tokens need to expire. If somebody is authenticating your token very rapidly, you need to lock that user out. And then you can have some sort of a rate limiting. So if attacks are coming in continuously, block that user for 30 minutes. That way he won't be able to do some sort of a lockout or weak password checks. Okay, I hope you understood this, guys. Okay, what else is there? Number third is excessive data exposure. This is pretty simple. Not going to spend too much time on this. This is basically the API simply gives a lot more data than is needed. Why? Because it thinks that the client, he is going to filter the data out. So maybe you asked for your email. Instead of that, just sending you your email back, I send you a whole user record back. I send you your user ID, password, credit card number, everything. Because I think, okay, the application on the phone, it's going to just show the email back. So I don't need to worry about the other stuff. That is why it's so dangerous, because the attackers, they can call the API directly and then they can figure it out, right? And they can do it multiple ways, right? So you can see this example, right? There's an API called retrieve address. So it's the guy says, please, what's my address? So it sends the address back, but it sends all the other details also. It sends you user ID, password, your PIN number, your credit card number. And you won't believe there are a lot of APIs who do this, right? They don't realize. What can I do? I can try to, if I was an attacker, I can try to directly, trick this API into sending me these details. I can try to intercept this data. I can try to compromise this client because I know the data will be stored there. So all these things you need to take into account, guys. So only show that what is needed. Need to know. So yeah, how to protect it? Never ever rely on the client application to filter your data, right? And you need to look at what your API is sending back. Are you only sending back that what is needed? If you're sending some PII or PCI data back, please do not do that. So you need to put these checks in to prevent some sort of data leakage happening. I hope you understood this now. Okay, moving on. Number 4, what is it? Oh, rate limiting. So basically, lack of resources or rate limiting. A lot of time, APIs, they don't impose any restrictions on the number of resources that a client can, request. And what can happen is if you send too big of a request, that the API can actually cause the backend application to crash. Because what is an API doing? At the backend, it's doing something which is consuming network or CPU storage, right? And if you don't have enough checks in place, it can lead to an actual denial of service attack. How can that happen? So let's take an example. Supposing there is a social media application, right? And Tim, what does it do? You basically send your family pictures back, like 50 pictures, right? It's going to create thumbnails and send you those thumbnails back. So this is pretty cool. I don't know what the issue is, but it takes a lot of resources to look at those pictures, extract them, unzip them, make them into small thumbnails. And what does the attacker do? He looks at this. Okay, this sounds interesting. I start sending like 1 terabytes of data. It's gonna completely choke the network, choke the resources. It's gonna cause a denial of service on the social media app. Okay, why? Because you're not looking at how much data is coming. You're not rate limiting it. You're not saying, okay, this maybe like, oh, you can only send 100 MB data. More than that, sorry, you cannot send it, because then the application will crash. So what you do now, you have to implement some sort of a rate limit on what a user can do within a time frame, right? And if it's getting exceeded, notify the customer, sorry, you cannot send more data there. You need to implement server-side validation, right? So make sure that the number of records are coming, they are like suitable, and enforce some sort of a size limit and all these things you have to do. So basically the risk here is denial of service attack. Okay, moving on. What else is there? broken function level authorization. What is that? This is pretty simple. I mean, the most simplest one is basically what people, and I've seen this quite a lot in APIs. What they do is users, they expose their admin level APIs through URLs. So they think nobody will be able to guess the URL, right? And they don't know these attackers. They're pretty smart, right? They understood. So with just by guessing the URL, they can actually access admin level functions. So functions are, you're just authorizing based on thinking that user will not be able to know where the function is. So let's take an example. So there is a function called retrieve info. So when you ask for the info back, it just sends the API like this. So it's like version1/user/myinfo. And the attacker, he says, okay, what if I removed it and I just put admin here in the subfolder? What will happen is it can actually gives you all the data because this is an admin level API function. So just this check, you thought that what the developers did, they thought no one will be able to guess that you need to put admin here. And this is something only the internal people know. No, unfortunately, this is something which can be guessed very, very easily. And the result is that you can now, the attacker now has access to the admin level functions. He can retrieve all through the API. He can retrieve everything. So this is the broken level function level authorization. Yeah. So what do you have to do? Don't rely on the client to enforce admin access. Please, you need to put in controls yourself. Don't think that if the user is sent, the user will not be sending admin. Okay. So make sure that the access is denied by default, whitelist it. Only the operations, like put some sort of a role-based access matrix based on where the IP is, what the user is, and put in proper multi-factor authentication or other stuff there. All these things you need to take into account, guys, please. Okay, moving on. Another thing is mass assignment. Was it mass assignment? Well, mass assignment is very simple. Simply put, what does it do? That when you're sending data, like you're writing data, right? Putting data to the API. What does the API do? It just like takes whatever information you're sending and maps it to the backend. It doesn't check that, okay, only like if the user is only sending the address, that is the only thing I should update. No, it takes the whole bulk request and just updates blindly without checking it. So what can happen here in this sort of attack? So let's see here. This is one guy called Tim. He wants to just update his name, phone, email, and he sends the record there. Okay. But what is happening at the back end is just like a credit scoring application, right? It's updating the whole record. Okay. It's just blindly taking the whole database field and it's just updating it. So what can an attacker do? He can do the same thing. He can say, okay, update my known phone email. He'll put one extra thing in my credit score. How does he know this? Well, I hate to tell you this. A lot of times these API details, they're publicly present in documentation, publicly present in GitHub. The attacker will just go to GitHub, go to public documentation. He will figure out this is how the API schema is. And it has this field also, credit square. And let me check by sending this. And actually it'll get updated. And this is something which has actually happened before. It happened in the States. A guy was able to completely compromise an API through this sort of attack. So I hope you understood this, why it's so dangerous. So protecting it is pretty, I think you can understand why it's so dangerous. Do not blindly just update stuff without looking at it. Explicitly look at what the user is sending, only update that data, okay? Precisely define it. Please do not just blindly update whatever it's sending and whitelist it. So you can say when the API is scanning, it can, this API update address, it can only update the address, it can't update anything else. And blacklist anything else, especially for sensitive functions. Okay, I hope you understood this, guys. Okay, what else is there? Security misconfiguration. This is like easily the most easy to understand because this is not just unique to APIs. This is pretty much present anywhere. So the attacker, what does he do? He finds patches, missing configuration flaws in the API or in the backend system. This is like a common thing, not just for API. People do not harden it. People do not patch it. Like you have things like the log4j, right? All these things can happen. Maybe your encryption is not there. So basically this can happen at pretty much any layer. It can look at the backend. The attacker can try to insecure configuration of the API, the insecure client. He'll try to find unpatched flaws, common endpoints, unprotected files to gain unauthorized access. So this is a very, very common attack. What do you do? This is pretty simple, right? You need to harden, patch your processes, patch your API, make sure your backend systems are secure, restrict admin access. These are pretty the standard hardening practices. I'm not going to spend too much time on this. Okay, number 8 is injection. Now, if you are in application security, I think you would understand what I'm talking about, right? You must have known about SQL injection. What is this? Basically, untrusted data is sent through the API to the backend, and you do not filter out the inputs which are coming in. And what can happen is you can actually make the application execute commands which it was not expecting. You can like inject your own malicious commands there. And in the worst case scenarios, you can do data leakage, you can disclose data, you can do a complete DDoS attack, you can completely take over the host. Injection attacks are some of the most dangerous attacks that can happen because you're not sanitizing. So what is happening here, this guy Tim, he sends there's a API called put file, right? So he sends a selfie and the selfie gets put at the backend, right? And you get a response back that selfie has been updated. So and what is happening is there are backend OS command being run through this API, right? And it's not authenticating. So what happens, this attacker, he sends his selfie, but he sends an OS command also delete the files. Because this command is going without any authentication, when this command goes, this application is going to delete all the files. So you're going to have a massive business impact because of this injection flaw. This is how SQL injection also used to work. So how to protect it is pretty simple. It's the same way as to SQL injection. Validate, do not trust any input, make sure all the input is sanitized, filtered. If any special characters are there, you need to sanitize it. The same things you do for SQL injection, please import the same to APIs also. Okay. Moving on. Number 9, we are almost at the end here, guys. Number 9 will be improper assets management. What does that mean, by the way? It's very simple. It's a very, very simple attack. You have APIs, right? Supposing you had an API version 1 and the API was not secure, and then you fixed it. Your security team found some flaws in it and they say, hey, you need to fix this, right? So you move to version 2. The only problem is you forgot to remove version 1 from the internet. So the old API version is still there. And attackers can actually find this through documentation and they can see, okay, the new API is quite secure. What about the old API? And actually, I can use that API to gain access because you forgot to remove that API's access. So what will happen is it will happen like this. Let's take a look. So yeah, this is what it would look like, right? So you have Tim, he's sending a request to the new API version 2.0, which for updating information. So name, phone, email, and the API is quite secure. It's checking everything through the credit scoring application. Awesome. And this is version 2.0. The only problem is there's a version 1.0 still there on the internet. So the attacker, all he has to do, he has to find this API, okay? And he sends name, phone, email, and the credit score. And he just updates this app. So your new app is all secure, your new API. Your old API is still secure and still present. Why would you think somebody would do this? Unfortunately, you won't believe a lot of time developers want to maintain backward compatibility. So some clients are there, still there on the old API. So they have to keep this, or your old and non-production versions. Maybe it's a UAT system, it's not there. And they just forget about it. You won't believe they forget about it because they don't have change management systems in place. So you can imagine why it's so important. You need to have an up-to-date inventory of all your APIs. And please remove everything which is not required to be there. Make sure those old APIs, they don't have access to production data, segregate it, and put additional controls like an API gateway. I'll discuss about that. And you need to have proper change management there to make sure that those old versions get retired properly. Okay, almost now we've reached the last one, which is logging and monitoring. Logging and monitoring is quite simple, right? Unfortunately, what happens is most of the times people forget to make sure that the API is logging properly. The API calls, which is happening, right? All the things with the APIs, the failed logins, what the API action taken, people are not producing logs, they're not storing logs, or they're not protecting those logs, or they're not monitoring those logs. What happens is if there's an incident, then nobody will be able to know what happened because the logs are not there. That's why you need to make sure these technical controls like an API gateway are there. So let's take a look at what I'm talking about. So let's take a look here. You can see this is the same attack as before. Same thing is happening, right? But now, assuming that your customers start complaining and they say, hey man, this happened, what do I do now? And you go back, you have no logs because you never turned on the logging thing. So this is what happens, unfortunately. And as a result of this, you're not able to do forensics. You're not able to go back, find out what happened. You're completely blind because you did not turn on logging. So, and how to protect against this? This is pretty simple, right? You need to make sure everything is being logged. Your API logs are writing properly. Enough data is there. If you need to send it to a SIM solution, make sure some sort of logging or archiving is there. Pretty much basic. A lot of people are very careful about their applications. They completely forget about their APIs. Okay. So guys, I hope this was a long lesson, but I hope you understood why API security best practices, these are so important. So now that you understood the attacks and how to protect them, let's take a look at the security controls. Okay. So what security controls are we talking about? Well, from the API perspective, you need to have training, which is very important. You need to have an API gateway, which I'm going to go into detail. And you need to have authentication. And of course, you need to have testing. These are the 4 pillars of a proper API security strategy. So what is an API gateway? API gateway, you can think of it as like a proxy server. It is something which sits between you and your API and all the other things which are consuming this API. So it's an interface. It's like, you can think of it like a single sign-on, and it sits in front of the API. It's a single entry point for all your APIs, and everything has to interact with this APIs. What's the good thing about it? It acts like a protector. So it makes sure that all the logging is there, all the authentication is there, throttling is there. So if somebody is sending 10,000 requests, the API gateway says, sorry, you cannot do that, and it will actually stop it. So it's like a front door for your applications, okay? And this way you can have like an inventory of all the APIs. So you can actually see which are the older versions, which are the newer versions. You can have access control. You can make sure proper security controls. So that's why I was saying, if you have lots of API gateway is definitely the need of the hour. And you can have a very powerful security controls enforced at the API gateway level. The second one is very simple. Of course, the API risks. You need the thing I told you, this course I've given you. Similarly, you need to make sure that you are like trained up, all your developers are trained, the security team is there. You have standards for API security. They're getting enforced, and you can audit them. And all your API logs are getting sent to the security system, so you know what's happening. This is very, very important, guys. API, if your developers are not aware of API security risks, you're going to have a big, big problem, okay? And what's the last thing, guys? Security testing of APIs. API vulnerable, like API testing, like your security system is broken. If your APIs are not part of your pen testing, if they're getting overlooked, or if your security team don't have the knowledge to test them, and if you're not testing properly your APIs, most of the time I've seen APIs are only tested by the development team, and the security team has no idea, okay, what APIs are there, what sort of what are the offensive attacks which can happen on API. So API security testing is the process of checking for vulnerabilities in your APIs, okay? Looking at the attack surface, what sort of things are there. So maybe you have an API create thumbnails. So you have like your pen tester sitting here, he's going to do all the OWASP attacks, right? And the security, the source code, he's going to do a source code review. He's going to do software composition analysis. What is that? So source code review will look at the source code to identify potential vulnerabilities, right? Look at what is there and make sure you use some sort of a tool. And the software composition analysis, it looks at the libraries, what sort of dependencies are there. And it checks if any of those libraries, like maybe there's an insecure Java version or anything like that, it's going to alert you. You need at a minimum, you need to have these sort of things there in your security program to have a proper sort of API security controls in place. So I hope you guys, like I was successful in teaching you like a little bit about this. It's no mistake that half of the what do you call OWASP security top 10 is pertaining to authentication and authorization, because this is what's happening, unfortunately. So make sure these things are there, and getting these security controls, it's a challenge at the first, but as awareness gathers and you create some sort of a program, definitely will see a lot of improvement coming in your security posture. Make sure these details are there, make sure your teams are aware, and then definitely you will see a lot of improvement coming in your security posture. Thank you, guys. I hope you enjoyed this video. I hope you understood what I was trying to say. If you like this video, if you'd like me to make more thorough, more technical details, please let me know in the comment section. Please do like, subscribe, and share this video, as it will help for the channel to grow. Thank you very much, guys. Thank you. I hope you like this mini course on API security best practices, and I will see you next week in the next